Welcome to the online physics channel. In this video we are going to learn how to apply Kirchhoff law, and the next lecture we will see some application or some example. So before going to the Kirchhoff law, let us learn some terminology. First, learn what we call a junction or a node. A point where two or more wire are joined is called a junction or node. Here the point N1, a point N2 are node. Here two more than two wire and three wire actually joined. Then there is another term which we call branch. A path connecting two nodes is called a branch. Here this side is a branch, also this side is a branch, so there is two branch. Now there is some step. So when we apply the Kirchhoff law, we will follow this step. If we follow this step, then problem become handy. Then we can easily solve the complicated problem also. So you will be given a circuit and will be asked to calculate some voltage or some current in that circuit. So first step is label the nodes. So here in the circuit N1 and N2 are nodes. Then assign current and direction of current in each branch. In some problem the current will be assigned previously in the question, but in some cases you have to assign current. So assign current and direction of current in branch. Like here we assign that from the voltage source V1, I1 current is emitting and same current will be returned to that voltage source because charge is conserved. Now in the R1, from the resistors R1 and R2, I2 current is flowing, and this side, this branch I3 is flowing, or I3 is entering this battery of voltage V2, and again this side I3 is coming out. So one thing is there, assign current arbitrarily. There is no such rule how to assign the current, but if you get a positive value for your current, then your assigned current direction was right, and if you get a negative value for the current, then the direction you assigned, then the direction you initially assigned was wrong. So that is the thing. There is no specific rule to assign the current. Just assign arbitrarily. If you get positive answer, your initial assignment was right. And for negative answer, you have to change in the diagram. You have to change the direction of the current only, but magnitude will be same. Then rule number 3, apply Kirchhoff current law at each node or junction that gives a unique equation. Sometimes you can get same equation in two nodes, then take any one of them. Otherwise, in each node or each junction, you will get a unique equation of current. You can get a unique equation from current law. Then step number 4 is go around each loop, apply the Kirchhoff voltage law. So in the step 3 we have to apply Kirchhoff current law in each junction. Here N1 and N2 we will apply Kirchhoff current law, and then the fourth step, go around each loop and apply Kirchhoff voltage law. So we have to make a loop in each branch. Here two branch, so we make here L1 and L2 loop, and we will go around this loop and apply Kirchhoff. So Kirchhoff voltage law, that is the thing, Kirchhoff voltage law. So we will see how to do that. So this is the basic 4 step. Now came to Kirchhoff current law first. Sometimes we call this junction law or junction rule. It states that sum of the current at any node is equal to 0. That means sum over I of I is 0. It is commonly used in parallel circuit. For example, if we notice this diagram, current passing through R1 is I1. The I1 current passing through R2 is I2, and current passing through R3 is I3. Now according to Kirchhoff current laws, this sum of these three current is 0. So before applying this, so there is another statement which will give us some idea how to take the direction of current. So another alternative statement of Kirchhoff current law is that current into the junction are equal to the current out of the junction. That means here the I1 current is coming into the junction. That means current I1 equal to current coming out of the junction. There is two current which is coming out of the junction. So the I2 plus I3, these two current is coming out of the junction. Now now we can take some convention. That is this statement already helped, that how to take the current and another convention is, for convention, take current which are coming into the node as positive and take negative for those who are leaving the node. So if we use that convention, so here I1 current is coming, I2 current is leaving, I3 current is leaving, that total sum will be 0. So according to this first Kirchhoff current law or Kirchhoff first law. So both this equation and this equation is result same thing, that both of them resulting I1 will be I2 plus I3. Now came to, so one important thing to remember, that current which are coming into the nodes are positive and take negative for those who are leaving the nodes. Now came to the Kirchhoff voltage law or loop rule. It is basically used for a series circuit. So it is stated, is the Kirchhoff voltage law states, the sum of potential difference or voltage across the element in a loop is equal to 0. That means sum over Vi is 0. So that means if we have some circuit, say some battery is there, some another battery is there, some voltage, so some resistance is there, R1, V1, V2, R2. Then if we go to this loop, then sum over all the voltages. That means V1 plus, if say voltage drop across the voltage of the battery, voltage drop across the R1 plus voltage of V2, about voltage of battery 2 plus voltage drop across R2, sum of all the voltages will be 0. So we will very soon come how to take care of the direction. So one thing is important, although we are showing this Kirchhoff law in such form, it is not a new thing. We already know that closed loop integral of E dot dl is 0, which are coming in other form, curl of E is 0, which implies that electrostatic field is conservative. Electrostatic field is conservative. Now we know V is like integration of E dot dl is potential. Not that it represents the potential. Now this integral is a closed loop integral. Now instead of integral, we are representing integral by a sum, because our voltages are discrete, not continuous. So Kirchhoff law is actually a manifestation or a other form of our conservation of electrostatic field. Now came to the convention, how to take the direction of voltage. First is across the battery convention. So here let us first come to here, that E dot DL, DL is direction of DL is representing here actually in which direction we are going. If we are going in the direction of electric field, then E dot DL will be just, then the angle, the cos theta will be 0 degree. That means E dot DL will be EDL. If we go opposite direction, that means if say E is in this direction, we are going opposite direction, then it will be minus E dot DL, because cos 180 degree will be there. Now came to our battery convention. So with that idea, so while we are going through a loop, if we go in the direction of electric field, so that means if we go the direction of electric field inside the battery is plus to minus in that direction, and if we go in the same direction, we will take the voltage of a battery as a plus. That means plus. If the voltage of battery is 6 volt, we will consider that it will be as a plus 6 volt. Again, in another case, if we go in the opposite direction of the electric field, so direction of the electric field inside the battery is in this direction. If we go in the opposite direction, so we will take negative voltage. Here, if the voltage of battery is 6 volt, we will take minus 6 volt. So easy tips is, what you saw first, take it. So while you are moving in the loop, so when you came near the battery, if you first saw the positive side of the battery, then take it positive. If you saw the negative side of the battery, take it negative. So that is a easy tip. What you saw first, take it. Then another convention is across the resistor convention. So later here consider the I current is going from the 10 ohm resistance. If we consider the current of direction of current in this direction, so current is going in this direction, means this is this side, this side is positive and this side is negative. So which implying that electric field inside the resistor is in that direction. So while moving in the loop, if we move in the direction of electric field, so we can take, so we will take voltage drop across the resistance, which is here in case of a 10 ohm into I ampere. Say let it write 10I without any unit. So we will take that as a positive. Or another sense we can say, if you are moving in the direction of current, you can take your voltage or voltage drop across the resistance as a positive. Now came to other case. If you move opposite to the electric field, again the current is in the same direction, the current as like before. So the direction of electric field in the resistance is in that direction. Now if we move in a loop in that anti-clockwise direction, here we are actually moving in the direction opposite to the electric field. In that case, we take the voltage drop across the resistance as a minus. Or you can remember it, if you go against the current, take it minus. If you go with current, take it plus. So we can write here, if you are going with current, take the voltage drop as positive, and if you are going opposite to that current, take the voltage drop across the resistance as a negative. So this is all the rule. In the next video we are going to apply all the rule and work out 2 examples so that you can understand how to apply it, how to apply Kirchhoff. So Thanks for watching. Now watch the next video, then you will get an idea how to apply the Kirchhoff law, and the PDF of this blackboard is given in the link, and the link of the next video also given link of the next video also given in the description, as well as the PDF copy of this blackboard will be given in description.